fx equal to x squared minus 1. Okay. For this function on this interval 0 to 2. Okay. On this closed interval. Okay. Fx for this function. Okay. Fx equal to x squared minus 1. So on this closed interval. So here actually this function we know that this function actually is continuous on this closed interval. Yeah.
Yes.
So this function actually is integrable on this closed interval. And now, so here we have 0 to 2 fx x squared minus 1. Okay, dx. So this definite integral actually is the right side area. So now first we plot the graph. We plot the graph of this function on this closed interval. So here actually is like this. Here when x equal to 0, here is minus 1. So here is minus 1. And when x equal to 2, here is 2 squared minus 1, so it's 3. So it's here. So actually it's like this. Okay, so it's like this. So here is 2. Here is 2, okay?
Yes.
So the net side area, so actually here we note that the area below the interval we denote by A1, and the area above, okay, the area above the interval we denote by A2. So this part, the area of this part we denote A2, this part we denote A1. So actually the definite integral actually this part actually is what? Is equal to what? Equal to the area above the interval minus the area below the interval, yeah?
Yes.
So equal to A2 minus A1, yeah? Equal to A2 minus A1, okay? Minus A1. So here now we give a kind of function. This kind of function is integrable, okay? So here, if a function is integrable, is continuous on a closed interval, just continuous on a closed interval, then that the function is integrable on this closed interval, okay? And the definite integral actually is the right side area, okay? The right side area. So now we give an example. So now we compute this here.
Yes.
Find the integral from minus 1 to 2, okay? So the integral is x plus 2 dx, okay? So find this definite integral, okay? So the second is find the from 0 to 1, here is the square root 1 minus x squared dx, okay, dx. So now we need to find these two definite integral, okay? These two definite integral. So the first here is x, the integral is x plus 2. So now we know that this function, okay, is continuous on this closed interval. This function is also continuous on this closed interval. So actually these two definite integral actually is equal to the right side area, yeah?
Yes.
So we plot the graph, okay? We plot the graph here. The first graph is y equal to x minus or x plus 2. The first is y equal to x plus 2 on this closed interval minus 1 to 2, okay? Minus 1 to 2. So we plot the graph. We plot the graph on this closed interval, okay? So here is x, here is y. So here is minus 1, here is 2. So when x equal to minus 1, y equal to what? y equal to minus 1 plus 2 equal to 1, yeah? So here equal to 1. So here is 1. And when x is equal to 2, when x is equal to 2, y equal to 2 plus 2 equal to 4, yeah?
Yes.
So here is 4. So now we can see that the graph actually is like this. It's a line pass through these 2 points. So actually it's easy to see that the dead side area actually is this part. This is the charm zone, yeah? So the charm zone, so here now we can see this upper base, okay, this upper base is 1, this lower base is 4. So and here this height actually is 2 minus 1 is 3. So actually this equal to what? This equal to the area of this charm zone, yeah?
Yes.
The area of this charm zone, so here equal to 1/2 times 1 plus 4, 1 plus 4 times what? Times 3, yeah? Times 3, so here equal to 15 by 2, okay? 15 by 2. So here means that the dead side area actually is 15 by 2. So here the definite integral one is 15 by 2, okay? 15 by 2. So this is the first one. Okay, now for the second one, now here, now we write y equal to the square root 1 minus x squared. X belongs to 0 to 1. Okay, x belongs to 0 to 1. So here it's not easy to see, the area is word short. So here we take a square on both sides, okay? We take a square on both sides. So here we have y squared equal to 1 minus x squared, yeah? So, and we plus, okay, we plus x squared on both sides. So here we have x squared plus y squared equal to 1, yeah? X squared plus 1 squared equal to 1. This is word short. Word short.
Triangle. Oh. It's triangle.
It's a circle, yeah?
Oh.
It's a circle, yeah? Here is x, here is y. So what's the center? The center is 0, 0. What's the rulers? The rulers is 1, yeah? So the rulers is 1. So here actually is like this. Now let's see here. Because x belongs to 0 to 1, so x actually is non-negative, yeah? So x is non-negative, so here actually is this part. It's this part. But here now we can see y actually is the square root, okay? Y is also positive. So x positive, y positive. So this shows actually is just this part, okay? Just this part. Just this part, okay? So here, just this part. So this part actually is 1 quarter of a circle, yeah? 1 quarter of a circle. So here now we just need to 1 quarter of a circle. So the area of a circle equal to what? Equal to pi times the r square, yeah? Here r equal to 1. So actually here is equal to 1 by 4 pi times 1 square, so equal to 1 by 4 times pi, okay? So the definite integral equal to 1 by 4 pi, okay? 1 by 4 pi. So here now we do an exercise. Now here we do an exercise. See page 299. 299. Number 12 to number 13. Okay, number 12 to number 13. use the area shown in the figure to find the integrals, the definite integral. Okay, so the definite integral. So do it now. Okay, I will ask you to answer the question. Okay.
5 to 13.
299, number 12 to number 13. Okay. So the net side area, okay? So the net side area means that the area above the interval minus the area below the interval. So here, this part AB, okay, the area above the AB, above AB is 0 to 8. Area below AB, below B is 0. So 0 to 8 minus 0. So here, if here from A to C, the area above AC, here is 0 to 8. The area below AC is 2 to 6. So 0 to 8 minus 2 to 6. Now let's see it, okay? Now here we say that the definite integral, okay? So the definite integral is dfx. The definite integral fx from A to B. This is equal to what? This is equal to the net side area, okay? So this is equal to the net side area. So the net side area. So the net side area, what's the definition of the net side area? So the definition of the net side area actually is what? The area above, yeah, above AB minus what? Minus the area below, yeah, below AB, yeah. So we just use this definition, okay? So now for the first one, okay? For the first one, for the 12, okay? Here, from A to B, here is A, here is B, yeah? So here, this is the graph of fx. So the definite integral of fx from A to B actually is the area above AB. So the area above AB is what? 0 to 8, yeah? So the area below AB is what? It's 0, yeah? It's 0. So this is equal to what? This is equal to 0 to 8 minus 0 equal to 0 to 8, yeah? So this is now for here the area. So the integral, okay? So the definite integral of fx from B to C. So here is B, here is C, yeah. Here is B, here is C. So the area above BC is what? Above BC, this part, okay? You just see this part. This part, okay? 0, yeah? So the minus the area below BC is what? So here the 0 minus 2.6, yeah? So the result is minus 2.6, yeah? And from AC, okay, so the area, so the integral, okay, the definite integral of fx from A to C. From A to C, okay? Here is A, here is C, yeah? So the area above AC is what? 0.8, yeah? So the area below AC is what? 2.6. So this is equal to what? This is equal to 0.8 minus 2.6, yeah? So the result is minus 1.8, yeah? And now here the last one is the definite integral of fx from A to D, okay? From A to D, here is A, here is D. Here is A, here is D. So the area above AD is what? 0.8, 1.5, yeah?
Yes.
Minus the area below AD, yeah? Below AD is what? 2.6, yeah? So the result actually should be 0.8 plus 1.5 minus 2.6, yeah? So the result is minus 0.3, yeah? 0.3. So this is for the number 12, okay? For the number 12. Now for number 13, okay? Now for number 13. For number 13, for the first one, okay? So the definite integral one, okay? So see the blackboard, okay?
Yes.
See the blackboard. So now. So the last point, yeah? The last point, you stand up and answer me. Answer me. So for the number 13 here, the definite integral of this, the definite integral of this equal to what? For this graph. Here, this part equal to what?
I didn't understand.
You can understand, so you are listen to me. When I introduce this one, you are listen to me.
Yeah, I'm listening to you.
So you listen to me. So here, you do not understand. I just ask you, okay? Ask you, you just see the blackboard. So you listen to me. Now for number 13, okay? Now for number 13 here, the definite integral of fx from A to B, okay? So A is here, B is here, A is here, B is here, so equal to the area above AB minus the area below AB, yeah? So the above AB is what? 10, below AB is what? 0. So here equal to what? 10 minus 0 equal to 10, yeah?
Yes.
Equal to 10. So this is the first one. The second one from BC, okay? So from BC, B is here, C is here. So the area above BC, what? 0. So the area below BC, 19.4, yeah? So here equal to what? 0 minus 19.4, yeah? So equal to minus 19.4, yeah?
Yes.
And number 3, okay, AC. Here is A, here is C. So the area above AC is what? 10, yeah. So the area below AC, 94, yeah. So here equal to what? So here equal to 10 minus 94 equal to what? Equal to minus 18.4, yeah. Minus 18.4. And the last one. And the last one, AD, okay, AD. Here is A, here is D, okay. So the area above AD is what? 10 and 9, yeah. So, and the area below AD, 94, yeah. So here should be equal to 10 plus 9 minus 94, yeah? So here equal to 19 minus 94 equal to what? Equal to minus 75. So here just keep in mind, okay, so the definite integral from A to B, okay, is just the left side area. Okay, the left side area. So you just need to find the area above AB minus the area below AB, okay? So now this is the first question. So which kind of function is integrable, okay? Now we answer the next question. Which kind of function is not integrable, okay? Which kind of function is not integrable? So here, now we answer the second question. So here, before answer the question, we introduce a definition. Means a function is bounded. Okay, a function is bounded. So here, now we said that a function f is said that is defined. Okay, this function f is defined on an interval I. Okay, on interval I is said to be bounded. Okay, be bounded on I. Okay, on I. Be bounded on I. So here this means what? If there is a positive number, capital M, okay, capital M, such that fx is greater than minus m, less than or equal to m, okay? Or what? Or actually this equality actually is equal to fx, the absolute value of fx minus less than or equal to m, okay? So here, this is the definition, okay? This is the definition of bounded. So if a function is bounded, means that this function is, there is a positive number m, such that the function is less than or greater than minus m, less than m, okay? Or the absolute value of fx less than m, okay, less than m. So this is the definition, okay, this is the definition. So now we give an example. So here we can see it from the graph, okay? We can see it from the graph. So here, for example, here is means that fx. For example, this is the graph of fx on I. Okay, on I. Here I is the subinterval from A, the interval from A to B. Okay, and here is y equal to m. Here is y equal to minus m. Okay, minus m. So here means what? Here means if a function is bounded, we can see it from the graph. Actually, is the graph of y equal to fx. The graph of y equal to fx is between the line y equal to minus m and the y equal to m. Okay. So if a function is bounded, okay, see it from the graph. Actually, is the graph of function. The graph of the function is between 9, y equal to minus m, and y equal to m. Okay, y equal to m. So here, now we can see here, just like this. Okay, just like this. So here now we give a function. Now we give a example. For this example, y equal to sin x. For this function, okay, x belongs to 0 to 2 pi. Okay, 0 to 2 pi. So here now we can see, we know that, okay, sin x, this function always less than or equal to 1, yeah?
Yes.
Greater than or equal to minus 1, yeah? So here we know that sin x always greater than or less than or equal to 1. Greater than or equal to minus 1 for any x. For any x belongs to 0 to 2 pi, yeah? So here means what? Here means that this function is a bounded function or not a bounded function? It's a bounded function, yeah?
Yes.
It's a bounded function. And now go on. Now let's see this function y equal to x squared on this closed interval from 0 to 2. From 0 to 2. For this function, okay? For this function on this closed interval. On this closed interval, actually we can plot the graph, okay? We can plot the graph here. Y equal to x squared from here is what? Here is 2, here is 4. Okay, here is 2, here is 4, here is 0. So now we can, it's easy to see that x squared actually is greater than or equal to 0, yeah? And in this closed interval actually is less than or equal to what? Equal to 2 squared, equal to 4, yeah?
Yes.
So here actually we have for any x belongs to 0 to 2. For any x belongs to this closed interval, we have x squared greater than or equal to 0, less than or equal to 4. So here now, yeah. So this function is a bounded function or not a bounded function? Not a bounded. Is it bounded or not bounded? Of course, it's bounded, yeah? So here, because we had here is m, here is minus m, so actually we can write it, here is 4, we can write it as minus 4. So actually x squared always greater than or equal to minus 4, less than or equal to 4, yeah? On this closed interval, yeah? So this function, of course, is a bounded function, okay? It's a bounded function. Hey, no. Here is here actually is 0, yeah? So here we know that x squared less than or equal to 4. Yeah, it's right, yeah? And it's greater than or less than 0, yeah? For here, x squared is greater than or equal to minus 4. Here is right or wrong? Of course right, yeah?
Yeah.
Of course right. So here x squared is greater than or less than or greater than or equal to minus 4, less than or equal to 4. For any x belongs to 0 to 2. Yeah, here is right or wrong?
Right. It's correct.
Because the interval is 0 from 0 to 2, not from minus 4.
It's of course for x squared always greater than or equal to minus 4. This part is right, yeah? This part is also right, yeah?
Right.
So the O is right, yeah?
Yeah, but the interval.
So here actually, here we just keep it here, okay? Keep it same, it's the same form, okay?
Now, see, can you explain last to last figure? Put up. Last to last.
Yeah.
You can ask to how many students understand this. I didn't understand this.
Here, no, okay? Now is so this is the graph, yeah? This is the graph. So this graph actually is between y equal to 4 and y equal to minus 4. Is right or wrong?
Yes.
This graph, okay, this graph is between y equal to minus 4 and y equal to 4. Is it right or wrong?
Right.
Of course, right. Yes. So this function is what? Bounded. Okay. So you can see it from what? From the graph. Okay. From the graph. So now this function is also bounded. Okay. It's also bounded. Now we give another function for this function. For this function, y equal to 1 by x. Y equal to 1 by x. Here x belongs to 0 to 1. So this function is bounded or not bounded? Y equal to 1 by x. X belongs to 0 to 1.
It's not.
So now, actually for this function, if it is bounded, we need to find what? We need to find an m such that 1 by x greater than or equal to minus m, less than or equal to m. Yeah.
Yes.
For any x belongs to 0 to 1. Yeah. For any x belongs to 0 to 1. Yeah. We need to find an m such that this is right. Yeah. But can we find this m? Actually, we cannot find this m. Okay. For example, because when x approaches 0, 1 by x actually approaches what? Plus infinity. Yeah. So here means that we cannot find an m. Yeah. We cannot find an m. So actually here this function is not bounded. Okay. It's not bounded. It's not bounded. So actually here it's easy. We can see it from the graph. The graph actually is like this. Yeah, it's like this. When x here is 1, here is 1, here is 0. When x approaches 0 from right, actually the graph, the y actually go to plus infinity. Yeah, plus infinity. So here means what? Here means we cannot find a y equal to n and y equal to minus n. So here we cannot find because the graph will go to up of y equal to n for any n. Yeah. So here for this function, okay, for this function is not bounded. Okay, is not bounded. Is not bounded on 0 to 1. Okay, on 0 to 1. Is not bounded. So here is bounded means that this equality is always right for any x. Okay, for giving n. For you can find an n. If you can find an n. But actually for this function you cannot find such an n. Okay, such an n. So here this function is not bounded. Okay, this function is not bounded. So here so here we have this result. Let f be a function that is defined under finite closed interval AB. Okay, closed interval AB. So if f has finitely many discontinuities in AB, but is bounded on AB, okay, then f is integrable on AB, okay? And if f is not bounded on AB, then f is not integrable on AB, okay? So here, if f has finitely many discontinuities in AB, but is bounded on AB, okay? Then f is integrable on AB. And if f is not bounded on AB, then f is not integrable on AB, okay? On AB. So here now we give an example. first example, this example, fx equal to here x, where x belongs to 0 to 1, okay? From 0 to 1, the left is closed, the right is open. And when x equal to 1, y equal to 3, okay? Y equal to 3. And when x belongs to 1 to 2, okay? The left open, the right closed, okay? Fx equal to x squared plus 1, okay? Plus 1. Now for this function, okay? For this function, now we need to determine the function is integrable or not integrable on this interval, okay? So now fx is integrable or not integrable, okay? Or not integrable on the closed interval from 1 to 2, okay? From 1 to 2. So here, for this function, okay? For this function, now we can plot the graph, okay? We plot the graph. So plot the graph. We plot the graph. The graph actually is like this. Here. Here is a piecewise defined function, okay? Piecewise defined. So here the first thing is when x belongs to 0 to 1, okay?
Yes.
0 to 1. Here is 1. Here is 0. Here is y equal to x. Y equal to x. So here actually is a 9. Okay, it's a 9. So this point is what? This point is 1. Is 1. So here, because here this is open, okay? So this is open. So here is open circle, okay? Here is open circle. This is the first part. Where x equal to 1, y equal to 3. So when x equal to 1, y equal to 3, 3 is here. So this is a dot circle, okay? And when x belongs to 1 to 2, y equal to x squared plus 1, okay? X squared plus 1. So here actually we can see when x here, so actually is like this, yeah? When x equal to 2, when x equal to 2. So y equal to 5, yeah? So this is 2, 5. So here this is the graph. This is the graph of the function. This is the graph of the function. Now, so it's easy to see the function is not continuous at this point, yeah? Because the left, now here we can see for this function, okay? For this function we can have what? The left limit where x approaches 1 from left. Where x approaches 1 from left. From left, fx approaches what? Fx actually approaches 1, yeah? The left limit where x approaches 1, okay? Where x approaches 1 from left. So fx actually approaches 1. So the left limit is 1. So the right limit is what? Where x approaches 1 from right. So the right limit, fx, where x approaches 1 from right. So fx actually approaches what? Approaches 1 squared plus 1. Approaches 2, yeah? And f1 equal to what? f1 equal to 3, yeah? So here means that the left limit not equal to the right limit. So actually the limit is not exist, yeah? So the function is, so here fx is not continuous, on x equal to 3, this point, yeah? But the function is continuous on other points, yeah? On other points. So here we have what? Fx only has one discontinuity. only has one discontinuities. In 0 to 2, this closed interval, okay? So fx only has one discontinuities in 0 to 2. And so here, the second function is bounded or not bounded. Why not bounded? Here is, of course, you can see that the graph is like this. So the graph actually is belonging y equal to 5 and y equal to minus 5, yeah?
Yes.
So the function is bounded or not bounded?
Bounded.
So fx is bounded. Fx is bounded. So the function is integral number or not integral number? So fx is integral number, yeah? So integral number on 0 to 2, okay? On 0 to 2. Just one discontinuities and bounded, okay? So the function is integral number on this closed interval, okay? So I will read. What?